now we come to the force of mortality. Okay?
Yes.
The force of mortality is defined as, it is denoted by mu x, and it is defined as the probability, it is in fact the conditional probability that your t is less than equal to x plus h given t is greater than x divided by h, limit h tending to 0. Fine. If you understand the basic definition of the probability for any continuous function of any continuous random variable, then you can always recognize the resemblance between the two definitions. Let me also point out that in words it is the probability of death between the ages x to x plus h, given that person has survived till age x. Fine. Where your h is so small. Okay. So, by this definition in words, what t is the future lifetime of a person. Fine. And this is in fact the future lifetime random variable for any person. If I say that there is a conditional probability which says the person survives till the age x, and then within age x to x plus h, within this interval the person dies, because this lifetime is less than equal to x plus h implies that the person would be probably dying within the interval age x to x plus h, and h is so small. This is shown by taking the limit h tending to 0 and by dividing by h. In fact, your mu x is also defined as the instantaneous rate of mortality relative to the number of policy holders alive at age x. This definition I hope is not readily comprehensible, but yes, very soon I'll be proving by mathematical derivation the funda behind this definition. And this definition is not listed in the book. What they have written, it is simply this expression, limit h tending to 0 probability this divided by h. Okay. So these definitions are important, and since you'll be getting the recording and you'll be having these recordings with you forever, so you need not to write these, but you need to keep these things into your mind. These are the alternative definitions which mean the same thing and which point out to the same thing. Mu x. Mu x is the force of mortality. You know, the force of mortality is in fact the instantaneous rate, or it is the conditional probability of death within a very small interval. What does this mean? What do these two interpretations mean? That mu x is a probability of death for a policy holder at every moment. That means if I have to calculate the probability for a continuous infinite decimal small interval, then mu x is that probability. But if I I divide the time points in the smaller parts, which have the length of large magnitude, like from 0 to 1 year, from 1 to 2 years annually. So these parts of the lifetime T for any person are having the lengths which are larger in magnitude and which are considerable lengths. Okay. So at these points, these discrete points, if I want to calculate the probability of death at any time say t, then it is qxt, and qxt differs from mu x in the sense that mu x is the probability of death for a person at every moment. Okay, and this qx plus t is the probability of death between age x to age x plus t. Okay. And this probability is defined only at discrete time points, okay, at integer time values. But this is defined